In this example, we have a word problem. And so let's go through this and figure out what math it is that we have to do to it. So it says we have a trail runner who programs her GPS unit to record her altitude in feet every 10 minutes during a training run in the mountains. The resulting data is shown below. So time zero, she starts at this 10,000 feet. And then every 10 minutes, we're increasing our feet as she's going up the mountain. And then meanwhile, at a nearby weather station, a weather probe records the atmosphere pressure P in hectopascals at various altitudes shown below. So at this altitude, this was the pressure, and it's decreasing the higher we go. Right. So it says use the chain rule to estimate the rate of change. So rate of change, so AKA slope, in pressure per unit time. So pressure per unit time. Right, experienced by the trail runner when she is 50 minutes into her run. Okay, so here's what we need. So if I kind of make sense out of this, pressure per unit time is going to be, we're finding a rate. So it's our change, our rate in pressure related to our change in time. The problem is we don't have a table that relates pressure with time. We have a table that relates pressure with altitude, and then another one that relates altitude with time. So that's actually our approach. So we are going to do, we can take this table and do the change in pressure with respect to altitude, and then we can multiply it by the change in the altitude. The change in the altitude with respect to the change in time. All right, so if we multiply that stuff together, the DAs are going to cancel and we'll get our change in pressure with respect to time. So this is a form of a chain rule. So here's the problem though. We do not have an equation. So since we do not have an equation to be plugging these things into, so the best that we're going to be able to do, the best we can do is an average. All right, so finding an average is we're essentially finding slope, right? So here's our math. First thing we're going to do is we're going to figure out if we can find the change in the pressure with respect to the change in the altitude. First off, she was talking about when she was 50 minutes into her run. So 50 minutes into her run, she is at an altitude of 12,330 feet. Well, we have a measurement at 12,330 feet, and that pressure was 793. Perfect. So since we don't have an equation, we're not able to find these instantaneous rates of change. So the best we can do is finding an average, which means I'm going to use this next value, and I'm going to use this next value to find slopes between them, which will be finding the change in pressure with respect to a certain amount of time. So let's do change in pressure with respect to altitude. So here's our change in pressure with respect to altitude. So this would be my change in pressure would be these values. So I'm going to do kind of a y2 minus y1. So 765 minus 793 divided by 13,300 minus 12,300. All right, so on the top, if we throw this in the calculator, we're getting a negative 28, and on the bottom, they differ by 1,000. So if I divide that, we are looking at negative 0.028 hectopascals per foot is what that would be. So we went down 28 in 1,000-foot change. All right, and then we're going to find dA dt, which would be us finding some information from this table. So we're going to find the change in our altitude with respect to time. So same kind of a thing. So here's our change in our altitude. So this would be my y2 minus my y1. 12,710 minus 12,330 divided by 60 minus 50. So at that time in her running up the mountain, we had a change of 330 feet in 10 minutes. So that becomes about 38 feet per minute. All right, so we got our pieces. Now we want to find the change in pressure with respect to time. So the change in pressure with respect to time is the change in pressure with respect to altitude times the change in altitude with respect to time, which we just found. So we have this one, and I'm going to make sure I put my labels into this and kind of line things up appropriately. We have a negative 0.028 hectopascals per foot, all right, times 38 feet per 1 minute. All right, so now if I multiply this together, cancel out my labels, feet are going to cancel, and we're going to get this value times 38. And if I multiply that together, that's going to give me a negative 1.064 hectopascals per minute. And that was the rate at which the pressure was changing with respect to time. All right, so that was a word problem involving a chain rule.